The Wärtsilä RT flex96C, commonly written 96C to reflect its 960 mm cylinder bore, is one of the most impressive heavy marine diesel engines ever built. It was developed by the Finnish company Wärtsilä Corporation and is intended for ultra-large container ships, providing extraordinarily high power at very low speeds. Below is a detailed description of its design, features, technical specifications, operational context, and significance. Design and purpose. The 96C is a two-stroke, low-speed, turbocharged diesel engine designed for main propulsion of very large merchant vessels, especially container ships. As a low-speed engine, running around 100 rpm or less, it's directly connected to the ship's large propeller with minimal reduction gearing, meaning the engine itself runs at low rpm for high torque output. Key design drivers. Very large bore, 960 mm, i.e., 0.96 meter, per cylinder. Long stroke, 2.50 meters. Straight, inline, cylinder arrangement, up to 14 cylinders in a row, for the largest variants. Use of heavy fuel oil, HFO, or similar high-viscosity marine fuels, as is typical for main propulsion marine diesel engines. Low RPM operation, example 102 RPM, for maximum torque, high power, and high thermal efficiency while driving large propeller shafts. Incorporation of advanced fuel injection technology, in the RT Flex version, that uses common rail injection rather than older CAMS half/gear-driven injection systems. This allows better control of fuel injection timing and quantity, resulting in better fuel economy, lower emissions, and smokeless operation at any speed. In essence, the 96C is a backbone marine power unit for very large merchant vessels where power, size, and efficiency all scale up massively. It is not a high-speed engine, like truck or car engines, but a gigantic slow-turning engine optimized for torque and fuel economy over long voyages. Technical specifications. Here are some of the key numbers characterizing the 96C engine, particularly the largest 4-cylinder version. Bore, 960 mm, 38 inches, per cylinder. Stroke, 2500 mm, 2.50 meters, per cylinder. Displacement per cylinder, approximately 1820 liters, 1.82 m superscript 3, depending on version. Speed, typical maximum around 102 rpm for full load, some sources indicate up to 120 rpm. Power output, up to 80,080 kW, 108,920 bhp, for the 4-cylinder version as of its first commercial service. Weight and size, the 4-cylinder version is about 26.6 meters long, 13.5 meters high and weighs over 2,300 tons. Torque, one source quotes 7,603,850 Nm at 102 rpm for the 4-cylinder version. Brake-specific fuel consumption, BSFC example figure 171G/kWh at full load. Efficiency, thermal efficiency in the range of 50% or slightly above, which is extremely high for a large reciprocating internal combustion engine. These specifications place the 96C among the largest reciprocating engines in the world, if not the largest, depending on metric. Its sheer mass, size, and power output are staggering in the context of marine propulsion. Operational context and application. The prime application for the 96C is in ultra-large container ships, ULCS. For example, the first 4-cylinder unit went into service on the ship Emma Maersk in September 2006. Because container ships of that era were growing in size, TEU capacity increasing, and required extremely high main engine power, in the tens of thousands of kW, to maintain service speeds, 20+ knots, and manage the hydrodynamic resistance of larger hulls, the 96C provided the required scale. Several operational features are noteworthy. Low operational speeds mean the propeller shaft can be large and efficient and coupling losses are minimal. The massive torque output allows the ship to carry large loads at moderate speeds without extremely high revving engines. Use of common rail fuel injection enables flexibility in running at part load conditions with better fuel efficiency and reduced smoke emissions. Smokeless operation at all speeds was cited in Wärtsilä's press release. Because of the large size, installation and maintenance require dedicated infrastructure, huge crane lifts, specialized engine rooms, major scaffolding. The sheer size makes them industrial installations within the ship. Engineering significance. The 96C represents a major engineering milestone for several reasons. Scale. It pushes reciprocating internal combustion engine design into enormous dimensions, many dozens of tons, multi-meter bore and stroke, thousands of kilowatts per cylinder. This pushes materials, manufacturing, machining, assembly, and installation to extreme challenges. Efficiency. Achieving 50% thermal efficiency in a two-stroke slow-speed marine engine is significant when one considers the fuel, load, and operating conditions. Fuel economy and emissions. With the use of common rail injection and turbocharging, the engine achieves lower fuel consumption and can meet stricter emission norms, given the size and type of vessels it serves. Reliability and lifespan. Marine propulsion engines are expected to run for tens of thousands of hours with periodic maintenance but no major overhaul for years. For an engine of this size, maintenance logistics are complex, so reliability is critical. Impact on ship design. By providing extremely high power at low RPM, the engine allows shipyards and designers to build larger hulls and carry more cargo, influencing container shipping economics and global trade. Some caveats and practical considerations. Installation footprint and weight. Because the engine weighs over 2,300 tons, for the largest version, the ship must be designed to accommodate that weight, maintain stability, structural support, and ensure that the engine room can physically fit the unit. Fuel type and bunkering. The engine runs on heavy marine fuel oil or similar high-viscosity fuels, which require appropriate bunkering, filtration, and handling systems. Emissions regime. Although advances were made for fuel economy and emissions, two-stroke low-speed marine diesels still have significant emissions of NO, SO, and particulates, so ships must often use scrubbers, exhaust after treatment, or slow steaming regimes depending on regulation. Maintenance complexity. The size and complexity mean that overhauls are major undertakings. Some maintenance may require dry docking and major disassembly. Even piston weight is many tons, crankshafts hundreds of tons. Technological advancement. The 96C was state-of-the-art in the mid-2000s, but shipping and engine technology continue to evolve. Dual fuel engines, LNG or methanol-fueled systems, hybrid propulsion, waste heat recovery. So while the engine remains impressive, newer propulsion paradigms are emerging. In summary, the Wärtsilä RT flex96C, 96C, is a marvel of marine engineering, a two-stroke, turbocharged, low-speed diesel engine with 960 mm bore and 2.5 m stroke, capable of outputting 80 MW or more, producing enormous torque at low RPM, and installed in the largest container vessels in the world. It embodies extreme scale, high efficiency, and advanced fuel injection technology, enabling large-scale maritime transport to operate effectively. While its size and operational demands are immense, the benefits in terms of power, fuel economy, and ship design make it an iconic engineering achievement in the marine propulsion domain.